Okay, so yesterday we talked about tangents and secants and how they intersect within the circle. They can intersect outside the circle, on the circle, or inside the circle. And what the relationship was between the arcs and the angles, right? That's what we talked about yesterday. Well, today we're going to talk more about secants and tangents, but we're going to look at the relationship formed between the segments themselves, okay? And the concept of this is not super hard. It's relatively easy. The theorems are really wordy, but I'm going to simplify those for you. The hardest part of this sometimes is the math, because we've got to go back and do some factoring, and I'm going to talk about the quadratic formula, which some of you covered last year, but probably most of you didn't. So it does get a little bit messy, but it's not, the concept itself is not really hard. And then there's two problems that, for whatever reason, they're not on your paper, but they're up here, so I'm going to have you write them down for kind of old school there. Okay, so our first theorem says that if two chords intersect in a circle, then the product of the measures of the segments of the chords are equal to each other. And what that means is we've got two chords, they intersect inside the circle, okay? And when that happens, the product of the parts are equal to each other. So I'm going to take A times C, and that is going to be equal to B times D. Now, when you do this, you have to make sure that the two things that you're multiplying together are part of the same chord. So A and C are part of chord AC, and B and D are part of chord BD, okay? So it has to be parts of the same chord that you multiply together. And the product of those parts are equal to each other. Okay, so now this is one where you're going to have to add this example here in just a second, so don't take up all of your space with this problem. All right, so we have two chords that intersect inside the circle, so we know that the product of those parts are equal to each other, okay? So what would I multiply together? 4 times 3 is going to be equal to 6 times x, good, okay? So I end up with 12 equals 6x. Divide both sides by 6, and x is 2. Okay, that one's real easy. Now this other one's a little messier because we've got all these variables that are involved, all right? But the idea is exactly the same. What should I multiply together here? X plus what? Okay, so we're going to do x times x plus 10, and then I'm going to take the other two and multiply them together. X plus 1 times x plus 8. Okay? Alright, so on this left side, I have to distribute, so I end up with x squared plus 10x. And then on the right side, we have to go back and FOIL. Okay, we haven't done that in a little while. It's a FOIL. So you got to do x times x, which is x squared, x times 8, which is 8x, 1 times x, which is x, and then 1 times 8, which is 8. Okay? So then we're going to simplify, solve for x. Now, in this one, we're lucky because our x squareds cancel, okay? And so we're left with 10x equals 9x plus 8. And we subtract the 9x from both sides, and we get x is 8. So that's really not hard. You just multiply the parts together, and you set them equal to each other. Okay, so let's apply this. Tunnels are constructed to allow roadways to pass through mountains. What is the radius of the circle containing the arc if the opening is not a semicircle? Okay, so this is not a semicircle. We want to know what the radius would be of this circle. Now, we could take and extend this around to actually be a circle, okay? And the height of this, which is the 32, the perpendicular length, is part of the diameter, okay? Because the diameter is the longest part of the circle. And so we could extend this down here, okay, to make the diameter. Now, we have the width of our road, which is 48, okay? What happens when the diameter is perpendicular to a chord? What does it do? It splits it into two congruent parts. So if this whole thing is 48, then each one of these parts are 24, okay? And so then we're going to let this part that we extended be x, and so now we have two chords that intersect in the interior, and we can do what we did above to figure out this length, and then once we know this length, we're going to add 32 to it. That'll be our diameter, and then we can find our radius, okay? All right, so One of the chords is broken into 24 and 24, so you're going to do 24 times 24, and then the other one is going to be 32 times x. And 24 times 24 is 576 equals 32x. We're going to divide both sides by 32, and x ends up being 48. No, that's not right, because that's the wrong. That's not the right thing. That's an old note. What is it? 18. Thank you. I changed the problem from when I did this the year before. Okay, so x is 18. So then to get my diameter, I'm going to take that length plus the height of the tunnel, which is 32. And so that gives me a diameter of 50. Okay, and so if my diameter is 50, then my radius is 25. Knowing how to do these kinds of things are important. Several years ago, I had a dad come and talk to my class about pigs. Anybody parents work in the oil and gas industry where they lay pipeline? Anybody's? Okay. They use these things called pigs, and they go into the ground and they use the radius, and it just circles around and it digs holes so that they can light the pipeline, and they have to be perfectly cylindrical. And so, anyway, he came and talked to us about a pig. I had never heard that it was called a pig before, but it kind of reminds me of that because they went in through a mountain and created at least part of a circle, you know, and so they do use geometry in that little aspect of the oil industry. Okay, now, this next little picture, we kind of need it for the next two theorems, okay? We talked yesterday about what a secant line was, and remember, a secant line intersects the circle in exactly 2 points. Well, a secant segment is part of a secant line, and we have what's called an entire secant segment, and we have an external secant segment. This right here would be the entire secant segment, okay? And then this is the external secant segment. Okay, they're both part of the secant line, but this would be considered the entire secant segment, and this is the external part. I will probably say the outside part and the whole thing, okay? Because this is the outside part, the external part, and this is the entire secant segment. And so you've got to know that for the next two theorems, okay? And I will tell you these are very wordy, but we will minimize it for you, okay? Put it into some English for you. But you do kind of need to know how to read these and apply them to the picture. If two secant segments are drawn to a circle from an exterior point, so a secant segment from an exterior point, then the product of the measures of one secant segment and its external secant segment, one secant segment and its external secant segment, the product, is equal to the product of the measures of the other secant segment and its external secant segment. Okay, very wordy, right? Basically what it boils down to is you take the external part times the entire thing, the external part times the entire thing, and those two things are equal to each other, okay? So your external part is A times the whole thing, which you have to add those two parts together. A plus B is equal to the outside part C times the whole thing, which you have to add those two parts together. So outside part times the whole thing, outside part times the whole thing, okay? All right. Okay, so it wants us to find RS, that's my unknown, and it says that PQ is 12, QR is 2, and TS is 3. Okay, so we're going to apply that, all right? We're going to take the outside part, which is 2, times the whole thing. What's the whole thing? 14. And then we take the outside part, which is x, and the whole thing is x plus 3. Okay, 3x is times. It's x plus 3. Okay? So outside part times the whole thing. Remember, you got to add the whole thing, add those two parts together. Okay, so now we're going to solve 2 times 14 is 28, and then we distribute the x. Okay, so does anybody remember what you do when you have an x squared and an x? You got to get it equal to 0, okay? Put it in descending order, so I'm going to bring the 28 over, and I get x squared plus 3x minus 28. Okay, so I get it equal to 0, I put it in descending order, and then I have to factor it, okay, if it's factorable. So remember from the first of the year, we did product and sum, okay? And our product, you take and you multiply the first and the last coefficient together, that's negative 28. My sum is the coefficient of the middle term, which is 3. So then I have to find two numbers whose product is negative 28 and whose sum is 3. So what multiplies together to give me negative 28 and adds together to give me 3? No. Okay, 7 and negative 4. Good. That multiplies together to give me negative 28 and adds together to give me 3. All right, so this one's easy because my coefficient is a 1, right? And so I can go straight to my binomials. X plus 7, x minus 4 equals 0. Once you get it factored, then you're going to set those two factors equal to 0 and solve. So x plus 7 equals 0, and x minus 4 equals 0. Subtract 7 from both sides. X is negative 7, and x is 4. Now, can I use both of those answers? No. Which one can I not use? The negative 7, because if I put negative 7 there, I can't have a negative 7 distance, right? So this guy's out. And so my answer is x is 4. Questions on what I did there? Everybody with me on that? I know you don't like to factor, but part of the whole algebra thing. You're going to get really good at it next year. I know we've done it here and there, and you did some last year, but you'll get really good at it next year. All right, now, here's another problem, okay? This time, instead of two secants, we've got a tangent and a secant, okay? And I'm going to read this, and then we're going to put it into English, okay? It says, if a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. So basically, what you take is the tangent segment and you square it, and that's equal to, just like we did above, the outside part times the whole thing, okay? So it goes back to that same thing. So the only difference is the tangent segment, you square it, and the other segment, you do the outside part times the whole thing, okay? All right, so tangent squared equals external times entire. All right, so that means we've got a squared equals, and my outside part and my whole thing, you have to add those two parts together. All right, that's what you do on that one. Now, I've got two problems to do here. Your paper only has one, so we'll have to add the second one. So leave some space somewhere for that second one, okay? All right, so we want to find x. Assume that segments that appear to be tangent are tangent. Okay, so I've got my tangent and I've got my secant. What am I going to do? 4 squared, and that's equal to, the outside part is x, and the whole thing is what? 2x plus 4, right? If you add those two parts together, okay? All right, so I'm going to clean things up here. 4 squared is 16. I distribute the x, so that gives me 2x squared plus 4x. Just like in the other problem, I want to get it all equal to 0, so I'm going to bring the 16 over. Okay, now before I get ready to factor this, what do I notice about each of these terms? You can all divide them by 2. So could I divide both sides by 2? Sure. Okay, so I'm going to divide both sides by 2. That's going to make my work just a little bit easier. So I end up with 0 equals x squared plus 2x minus 8. And so now I have a problem like I did before. And so I'm going to do product and sum. What's my product? The first and the last coefficients, multiply them together, and what do you get? Negative 8, and my sum is 2, okay? So I want two numbers whose product is negative 8 and whose sum is 2. 4 and negative 2. Good. Okay, my coefficient is a 1, so I can go straight to my binomials, correct? So it factors into x plus 4, x minus 2. Once I get it factored, I set those factors equal to 0, and my answers are -4 and +2. Can I use both of those answers? No. Which one can I not use? The -4, because I can't have a negative distance. You always test it though, because sometimes you can plug it in and it becomes positive, but in this case it's not going to. Okay, last one. Alright, so in this problem, I've got a tangent and a secant, so I'm going to set it up like I did the one above. Okay, so what's that going to look like? 8 squared equals, okay, x times 7 plus x, or x plus 7. I'm going to do x plus 7. Okay? Alright, so 8 squared is 64, and I distribute the x, so I get x squared plus 7x. Again, I've got an x squared and an x, so I got to get it equal to 0. Move that 64 over. Now, if I go to do product and sum, my product is -64 and my sum is 7. Can you think of two things that's going to multiply together to give me -64 and add together to give me 7? You got 8 and 8. That's not going to work. What do you got? What, 4 goes into 64 how many times? That's not going to work. That's too far apart anyway. 4 and 64, that's too far apart. I mean, 4 and whatever. Let's see, 64 divided by 4. Those 16 and 4, that's not going to work. Okay? So, 12 would go into that. No, it goes into 16. So that doesn't work. Okay? So, when you end up with something that doesn't work, you can't factor, obviously. So what you have to do is you have to rely on the quadratic formula. How many of you talked about the quadratic formula last year? Okay, a couple of you did? Okay, good. Okay, this is what the quadratic formula looks like. And the quadratic formula really works for any quadratic, no matter what, okay? But it's just messy. It's not my favorite thing to do, okay? It's not hard necessarily, it's just messy. And so what you have to do is you have to look at your equation in standard form. And the standard form of your equation is ax squared plus bx plus c equals 0, which is what we have over here, right? Okay? The a is the number in front of your x squared. So my a here is going to be 1. Your b is the number in front of the x, which in this case is 7. And then your c is always your coefficient, but you have to take on the sign that's in front of whatever you're working with. So my c is -64. Okay? And so that is the my a, my b, and my c. And so what I can do is I can then plug it into this kind of ugly looking formula and figure out what my solutions are, okay? And if you go to YouTube, there's all kinds of little ways to remember this formula. I always remember the Gilligan's Island. Some people do it to Pop Goes the Weasel. I can never remember how Pop Goes the Weasel goes. But if you want to remember it, you can do like the Gilligan's Island, a negative b plus or minus the square root of b squared minus 4a times c all over 2a. And if you know Pop Goes the Weasel, you can do it to Pop Goes the Weasel too, okay? So that's one way to remember. And you'll probably use this a lot more next year than you are going to use it this year. But let's go ahead and plug it in, and let's plug it into our calculators, because sometimes it's a little tricky getting it plugged into your calculator. All right. So we have our a, our b, and our c, okay? Everybody got their calculator out? We want to write it down first, and then we'll worry about plugging it in, okay? All right. So my b is 7. So it says negative b, so that's going to be -7 plus or minus the square root, and it says b squared, so that's 7 squared minus 4 times a, which is 1, times c, which is -64, all over 2 times a, which is 1. Okay? So all I've done is plugged it into that formula. I replaced my a, my b, and my c. Okay? So then I'm going to simplify. I've got -7 plus or minus. That's going to be 49. Now, notice up here. Look up here. You've got -4, 1, and -64. When I multiply these three things together, I'm going to get a positive. Okay? So what's 64 times 4? 256. So that's going to end up being plus 256. And then it's over 2. So I'm going to simplify it one more time. okay? And it ends up being negative 7 plus or minus, is it 305? Square root of 305 over 2. Now, see how it's got this plus or minus? Remember, every number has two roots. You got a positive root and a negative root. So you have to do two different problems. You have to do negative 7 plus the square root of 305 over 2 and negative 7 minus the square root of 305 over 2. Couple of things you need to remember when you put it into your calculator though, okay? Everybody got that written down before I tell you this important piece of information. Since your numerator is a quantity, you've got to group it in a parenthesis. So when you go to plug it into your calculator, you need to open up a parenthesis first. This is a negative, not a minus, okay? And then your radical, you should open and close a parenthesis around it and then close the parenthesis around your numerator, okay? And you're going to do the same thing with the other. So open parenthesis, negative 7 plus the square root of 305, close parenthesis, divided by 2. And you should get 5.23. So everybody plug that in and make sure that that's what you get. And then try doing the second one, but remember, this is a negative and this is a minus, okay? And if you don't get the answer, let me look. That way I can figure out what you typed in wrong. Got it? Okay, now if you have these new calculators, the CEs, just get out from underneath the radical. You may not want a parenthesis. If you've got those CEs, yours is going to look more like open parenthesis, negative 7 plus, and you're going to put the 305. Make sure you get out from underneath the radical, then close the parenthesis, divided by 2. Okay? So that might fix most of yours. If it's syntax error, that just means you typed it in. Okay, you have to double close the parenthesis. So you close it around the radical, but you didn't close it around the numerator. Oh, okay, here's the backwards. Okay. So what you're going to do is run 305 square root here, 305 square root. Then we're going to add 7 negative. Right here, see that little negative? Okay, equals, and then divided by 2. The other one, like if you do the other one, when you subtract on this one right here, you're going to do 305 square root, and then hit negative. You gotta make it negative, and then you add 7 negatives. Okay, and divide by 2. Okay. All right. You're gonna get that. Oh, here's the backwards too. Okay. So you've got 305 square root, okay, plus 7 negative, okay, 7 equals divided by 2. Okay. You got one. And then when you do the negative one, okay, like minus, you're going to do 305 square root, and you take that negative, and then you add 7 negative, and you hit enter, and then divide by 2. Okay. You should get 12.2 for the second one. Okay, type it in there so I can see what it looks like, and I'll come right back. That way I can tell you what's going on. Which one's this one? The second one? Oh, yours is not. Okay, you load, and you gotta get out of manual print. There. Okay, now try it. is a negative. Okay. Kylie, did you get yours in? Did you get it? Oh. Okay. You need to go to mode and you need to get out of math trend. Okay, now try it. Okay. All right. So let's go back over real quickly what we talked about, and then I'll come around and I'll help you with your calculator questions, okay? You should, like I said, you should have gotten negative 12.2, but can you use this as your answer? No. This guy's out because he's negative, so my only answer here is 5.23. Okay? Now, just to be honest, probably on your test, I won't give you one with the quadratic formula. There are a few in your homework, okay, that you're going to have to do. There very well could be one you had to factor, though. So you need to make sure you really understand that. This is good to learn because, like I said, the quadratic formula will even work for those that you have to factor. It's just messy, okay? So, real quickly, what we talked about, really basically 3 scenarios. If you have 2 chords that intersect in the interior, then the product of the parts are equal to each other. So A times C equals B times D. That was the first thing we talked about. The second thing is when you have 2 secants that intersect in the exterior. And remember, that's the outside part times the whole thing. You have to add those parts together. Outside part times the whole thing. And then the last scenario was the secant and the tangent. And what do you do to the tangent segment? You square it, right? And then that's equal to the outside part times the whole thing like we did above. Okay? All right. So your assignment is on page 753.